Session 6.1 Inverse Circular Functions. We call that for a function f, every element x in the domain corresponds to one and only one element y, or f of x in the range. If a function is defined so that each range element is used only once, then it is called one-to-one function. Remember, in the algebraic class, we learned what is one-to-one function. Each x value corresponds to only one y value, and each y value corresponds to only one x value. Look at this example. This is not the one-to-one function because the y value of the 7 corresponds to x value 2 and 3 here. So this is not one-to-one function. Inverse function. Inverse functions of one-to-one function f is defined as follows. This is the definition. The f -1, this is the notation of inverse function, saying that inverse function y and the x and y belongs to the f. So we do have a function f here, and then the coordinate is xy. How can we find the inverse function? We could just switch the x and y, become y and x. That would be the inverse function. Look at this example. Suppose we have this function f. Before we finding the inverse function, make sure this is one-to-one function. Okay, so you could see each x value corresponds to only one y value, right? They don't have a repeated something in. And each y value corresponds to only one x value. So now we can find the inverse function. So inverse function, you will switch the x and y coordinate in here. So you could see inverse function, the x become the y become the x. Same idea here. That is the x become the y becomes the x. So this is called the inverse function. Keep in mind, inverse function has to be one-to-one function. Caution 1. The negative in f, negative here, is not an exponent. Don't consider this is going to be the exponent. Okay, so some students write it like this way: f inverse x equal to 1 over f of x. This is not true. Okay, the f -1, this is the notation of inverse function. It's not related to the exponent. Review of inverse function. In a one-to-one function, each x value corresponds to only one y value, and each y value corresponds to only one x value. If a function f is one-to-one, then f has an inverse function. The domain of f is the range of the inverse function, and the range of f is the domain of the inverse function. So when you have the domain of the f, that will become the range of the inverse function, and then the range of the f, that will become the domain of the inverse function. Okay, the graphs of f and the inverse are refractions of each other across the line y equal to x. When you graph it, the f, the inverse function, will be the refractions across this line. How to find the inverse function? Follow this step. First, we're gonna replace f of x with y, and then interchange x and y. Whatever you see the x, you make it like y. When you see the y, you make it like x. And then solve for your y here. Replace y with the inverse function. How do the graph of a function and its inverse compare? Okay, remember we say that the graph of the inverse function is a refraction of the graph f across the line y equal to x. Look at this example. Let's say my f is going to be a and b. Only one coordinate. So the inverse f, that will be b and a. So this is going to be the inverse function. Now, I'm gonna graph the straight line y equal to x. So you could see these 2 points will be the refraction, just like you put the mirror in the middle here. And then the function f, x cubed minus 1, okay? And then the f of x equal to x cubed minus 1, we could use the previous step here to find the inverse function. When I graph it, you could see the inverse function is a refraction of the graph of f across the straight line, the y equal to x. Okay, now, inverse trigonometric functions. Does y equal cosine x have an inverse? Not really, right? Because we say if we want to find the inverse function, the function has to be one-to-one function. So obviously, this is a periodic function. It won't be one-to-one function, right? However, we could restrict the domain and then make the y equal to cosine x has an inverse function. The restriction must be include all possible values of cosine from 1 to negative 1. From negative 1 to 1. If possible, we want to restrict the domain include the x equal to 0. So we want to include this part, x equal to 0 here. So how can we restrict the domain to make it like one-to-one function? We'll be cutting this part here. So my domain will be from 0 to pi. And then from 0 to pi, this is a one-to-one function. Okay, we just cut this part of the graph. This is a y equal to cosine x. And then we'll be using the table, okay, talking about like this graph here. When x equal to 0, y equal to 1. When x equal to pi over 4 is somewhere like here. It's supposed to be rectangle over 2. When x equal to pi over 2, that would be equal to 0. Okay? And then 3 pi over 4, like here, that would be negative rectangle over 2. And then when x equal to pi, you will have the negative 1. Okay? We only talking about y equal to cosine x. Now, think about it. What is the domain? Domain will be the possible values of x. So talking about like here. So domain will be from 0 to pi. And then the range will be from negative 1 to positive 1. Okay, do we have the x-intercept? Yes, right? That will be pi over 2 and 0. Y-intercept? 0 and 1. Now we do have all the information. We want to sketch the inverse function, y equal to cosine negative 1x. So what we're gonna do, remember that how to find the inverse function? We could switch the x and y coordinate. Okay, so I do have the y here. I'm gonna put the y to the x here. I try to put it in order, okay, starting from the negative. So negative 1, negative rectangle over 2, 0, rectangle over 2, and 1 here. Okay, one more time. The y will become the x. And then the x, that will become the y here. Okay, so I just copied pi, 3 pi over 4, pi over 2, pi over 4, and then the 0. Now, based on this table, I want you guys try to sketch the inverse function of cosine x. Okay, you should get the graph like this. Now, think about it. What's the domain? Domain will be the possible values of x, so that will be -1 to 1. How about the range? Range will be starting from 0 to pi. Okay, remember that when we say have the function f and the inverse function f here, the domain will become the range, exactly the same thing. And then the range, that will become the domain here. Okay, how about x-intercept? X-intercept, that will be 1 and 0, similar to this guy. Y-intercept will become the x-intercept. And then the x-intercept will become the y-intercept. Okay, I need you guys remember the inverse function of the cosine x, remember the domain, and remember the range. Okay, let's work on the example. Find y in each equation. So y equal to arc cosine 1, okay? Arc cosine 1, we could revise it like this way. Cosine -1 here. And this is talking about cosine y equal to 1. Make sense to you guys? This is exactly the same thing. Arc cosine 1, or you could put cosine -1 here. And then cosine y equal to 1. Remember what is the range for the inverse function? Y will be from 0 to pi. Okay, y will be talking about the range. And then we know the range is from 0 to pi. You could double check here. The range for the inverse function is from 0 to pi. Okay, you have to remember that. So think about it. Cosine what number? That will be equal to 1. And that number has to be inside this range. Cosine 0 will be equal to 1, right? So y will be equal to 0. Okay, B, same idea. I will have a cosine y equal to -2/2. Again, state the range for the y. So that will be from 0 to pi. So what is y equal to? We need to get -2/2. And the y has to be in between 0 to pi. That will be 3 pi over 4, right? So y equal to 3 pi over 4. Look at the picture here. Okay. Each trigonometric function has an inverse only if it has a restrict domain. Identify the restriction for f of x equal to sine x based on the criteria. So now we want to find the inverse function for the sine. And then again, you know sine x is a pivotical function. So this is not one-to-one. So this is not one-to-one function. We have to restrict the domain. And then based on the criteria, the restriction must include all possible values of the function and should be include the x equal to 0. So we do have the sine curve here. Okay, this is not one-to-one function and we try to restrict the domain. And we want to include all the possible values and has to be one-to-one function and also including x equal to 0. So we're gonna cut out this part. So my restricted domain will be from -pi/2 to pi/2. Okay, we cut out this part. And then we have the table. I want you guys try, based on this table, fill in the numbers here. Okay, check your work. X equal to negative pi over 2, that will be equal to negative 1. Negative pi over 4, so that will be negative wet 2 over 2. 0, that will be 0. Pi over 4, wet 2 over 2, pi over 2, that will be equal to 1. Okay, what's the domain? Domain will be from negative pi over 2 to pi over 2. The range, negative 1 to 1. X and y intercept is going to be equal to 0, 0, the origin. Okay, I want you guys try find out the inverse function of psi. Remember x, that will become the y here. Y will become the x. And then find out the domain and range as well. The domain will become the range of the inverse. And then the range will become the domain of the inverse function. And then sketch the graph. Try. Okay, check your work. All the x will become the y, and all the y will become the x. Okay, right? Based on the table, you should have the graph looks like this. Make sure the direction is a little bit different from the side here. Okay, this is like kind of like smooth going up and then going down. And this one, you could just shift the paper and then it's going to be going like that way. And then the domain will be the range, negative 1 to 1. And then the range will become the domain here, negative pi over 2 to pi over 2. Memorize the range, okay? X and y intercept, that will be the origin. Okay? Example 2, find y in each equation. Since they are talking about the odd side, you need to remember the range of the y here. And then odd side, I could revise it to y equal to sine inverse 1/2. So sine y will be equal to 1/2 here. What is the range? Range is from negative pi over 2 to pi over 2. Okay, sine what numbers will be equal to 1/2? That will be pi over 6, right? So y, that will be equal to pi over 6. Okay, B. This is means sine y equal to negative 1, right? And then one more time, write down the range. The y here, it has to be inside on this range. So, sine negative pi over 2, that will be equal to negative 1. So y equal to pi, so y equal to negative pi over 2. Okay? Okay, C. Sine y equal to negative 2. And then, since the domain here, it has to be from negative 1 to 1, right? And the negative 2 is going to be outside of this domain. So we know that sine inverse of negative 2 does not exist. When you're using the graphic calculator, they're gonna give you the error message. Okay, question 2. Be certain that the number given for an inverse function value is in the range of the particular inverse function being considered. Every time when you guys deal with the inverse function, make sure you guys remember the range and also the domain. Okay, inverse of the tangent function. So if you guys remember the tangent function, it's gonna be p-vertical like this. And then we do have the vertical asymptote. And then they're gonna repeat it from here and then like that. So we're gonna restrict the domain from negative pi over 2 to pi over 2. So one more time, based on this graph, write down the values here. Okay, now we're gonna fill in this table. Since the negative pi over 2, this is the vertical asymptote. So we don't want to including to this table. So we're gonna start with negative pi over 4, and then we may take one more points. So I would choose like something here, which is negative pi over 6, because this is a special angle. And then we will have the 0, and then pi over 6 again, and then pi over 4. Okay, try fill in this table. Negative pi over 4, that will be equal to negative 1. What is a negative pi over 6? Negative 3 over 3, 0, and this 2. Okay, what is the domain? Domain talking about the possible values of the x, so negative pi over 2 to pi over 2. But be careful, I'm gonna put the parenthesis instead of the blanket, because x cannot be equal to negative pi over 2. This is the vertical asymptote. And then the range, that will be from negative infinity to positive infinity. X and y intercept, 0, 0. Okay, here we're gonna add one more. What is the vertical asymptote? That will be x equal to negative pi over 2 and x equal to pi over 2. Now, sketch the inverse function of the tangent. Do the same thing. Value of x will be equal to the value of y here. And then the x here will become the y. You would just exchange it. Okay. And also, we do have two vertical asymptote here. So when you exchange it, it will become the horizontal asymptote. So y equal to negative pi over 2 and y equal to pi over 2. You should have the graph like this. What is the domain? Domain will be the range of f of x. And then the range will be the domain of f of x. Okay? Exchange here. And x and y intercept, same thing. Vertical asymptote will become horizontal asymptote. Okay, since it's horizontal, so that'll be y equal to negative pi over 2 and pi over 2. Inverse of cotangent functions. So I have you guys restrict the domain already. So that will be from 0 to pi, and this is the graph of y equal to cotangent x. And then this is gonna be the inverse of cotangent x. I want you guys try to fill in all this information. First, y equal to cotangent x, what is the domain? What is the range? What is the vertical asymptote, x-intercept and y-intercept? Okay, let's check the word for the domain. I restrict the domain from 0 to pi. Okay, make sure you use the parenthesis instead of the bracket. And then the range, that will be from negative infinity to positive infinity. Vertical asymptote. We do have x equal to 0 and x equal to pi. X-intercept, that will be pi over 2. And then we don't have y-intercept. Okay, how about the inverse of the cotangent? Remember that the domain of the cotangent x will be the range of the inverse of the cotangent x. So for the domain here, that will be the range. So the domain will be negative infinity to positive infinity. And then the range, that will be the domain from here. So that will be 0 and pi. Since we do have the vertical asymptote, right now it will become horizontal asymptote. So that will be y equal to 0 and y equal to pi. Okay, we don't have the x-intercept. Y-intercept, that will be 0 and pi over 2. Inverse of the secant function. So this is the graph of y equal to secant x. We restrict the domain will be here from 0 to pi. We need to make sure it has to be one-to-one function. Okay? And then this is the inverse of the secant x. Okay, now please try to fill in all this information. So the domain, that will be from 0 to pi. But x cannot be equal to pi over 2 because we do have the vertical asymptote here. And then make sure we use the brackets here. And then the range. Range is from negative infinity to negative 1. And then starting from 1 to positive infinity. Vertical asymptote, x equal to pi over 2. We don't have x-intercept. Y-intercept, that will be 0 and 1. Okay, only this point, y-intercept. Okay, what is the inverse function of the secant x? What is the domain? You could copy it from the range here, right? That will be my domain. And then the range, I'm gonna copy from the domain here. We only need to change that. For the y equal to secant x, we do have the vertical asymptote, x equal to pi over 2, right? So the domain will be x cannot be equal to pi over 2. Right now, it becomes the range. So it will become y cannot be equal to pi over 2 here. Horizontal asymptote, y equal to pi over 2. X-intercept, we do have a 1, 0. Y-intercept, none. Okay, last one. Inverse of cosecant function. Similar to the y equal to secant x, we want to restrict the domain and make sure it has to be one-to-one function. Okay? Try fill out all the domain and range and x and y intercept and then asymptotes. Okay, check your work. The domain, it will be starting from negative pi over 2 to positive pi over 2. However, we do have the vertical asymptote here. So x cannot be equal to 0. The range, that will be from negative infinity to negative 1. And then 1 to positive infinity. Vertical asymptote, x equal to 0. X-intercept, none. Y-intercept, none. Okay, how about this one? The domain, same idea with the range, and then the range, that will be the same idea with the domain. Only like change the vertical asymptote to horizontal asymptote, y equal to 0. Okay, horizontal asymptote, y equal to 0 here. X-intercept and y-intercept, both of them are none. Okay, this is the summary of inverse function values. Okay, we do have the 6 trigonometric functions or the inverse function. I need you guys remember all the range here. Okay, I need you guys remember all the range, the y. Or you could just remember the quadrant of the circle. Okay, but it would be better if you guys can remember exactly it's going to be equal to or not equal to. Okay, this part. Example 3. Find the degree measure of theta in the following. Theta equal to arctangent 1. Okay, so theta equal to arctangent 1, we're going to look at it. Arctangent 1, it has to be in the range from negative pi over 2 to pi over 2. And we want to use the degree measure. So I write it down, the theta must be in negative 90 degree to positive 90 degree. And then we write this guy, that will be tangent theta equal to 1. Since tangent theta equal to 1 is a positive, right? And this is talking about either quadrant 1 or quadrant 4, right? Negative 90 degree, right? So since this is a positive, so the theta has to be in quadrant 1. And then what theta of tangent is going to be equal to 1? That will be 45 degree. Okay, one more time here from negative 90 degree. So negative 90 degree, that will be go clockwise. So that's talking about quadrant 4. And then 90 degree, that will be quadrant 1. Okay, so you could double check tangent functions, quadrant 1 and quadrant 4. Okay, one more time, since this is a positive, tangent in quadrant 1 will be positive. Okay, so it's going to be 45 degree. Okay, B, theta equal to secant inverse of 2. Okay, look at the secant. Secant of 2, the range, that will be from 0 to pi over 2 and pi over 2 to pi. Okay, so again, we're going to put it in the degree. And then we write this guy, so tangent theta equal to 2. Theta must be in 0 to 90, that's a quadrant 1, and this is going to be on quadrant 2. Secant has to be positive, so it has to be quadrant 1 here. And then we could revise it, sine theta, I could make it like cosine theta, right? So reciprocal of this guy. So cosine theta equal to 1/2. So theta will be 60 degree. Okay, example 4. Find y in radians if y equal to cosecant -1, -3, 1 to 2 decimal space with the calculator in radian mode. Okay, so cosecant, since I will be using the calculator, so I will change it to the sine first. So reciprocal of this guy. So y equal to sine inverse -1/3. And then try to use your calculator, you should get this number. And then 1 to 2 decimal space, so that will be -0.34. Okay, B, find theta in degree if theta equal to arc cotangent negative 0.3541. So we could divide it. Cotangent theta will be equal to negative 0.3541. And then what is the restriction for the cotangent? Cotangent, that will be 0 to pi. Okay? From 0 to pi. And cotangent, I can revise it to tangent. So tangent theta equal to 1 over this guy. From 0 to pi, so it's cosine 1 and cosine 2. And then tangent will be negative. So the theta will be in cosine 2. Use your calculator. So the theta will be 180 degree minus tangent inverse 1. You could see I take out the negative because the negative is telling you which cosine is it. Okay, so I use the negative. I figure out that will be cosine 2. Here, I will just finding the reference angle. Reference angle in cosine 2, I will subtract from 180. So you should get 109.499 degree. Example 5. Evaluate each expression without a calculator. So first one, sine of tangent inverse phi over 2. So first, we need to decide the theta will be in which quadrant. So tangent inverse equal to positive phi over 2. And remember the range of the tangent, it has to be either cosine 1 and cosine 4. And then tangent of phi over 2. Phi over 2 is positive. So you know that the theta has to be in cosine 1. So now we're gonna let tangent theta equal to tangent inverse of 3 over 2. And then we will write this guy. That will be tangent theta equal to 3 over 2. And we know this is gonna be in cosine 1. So we could sketch the theta in the cosine 1 and then label the triangle. Okay? Opposite over adjacent. And then we need to figure out what is your hypotenuse. So remember the formula, r squared equal to x squared plus y squared. Plug it in. You should got r equal to rad 13. Okay, that will be the hypotenuse. Okay, now gonna look at this guy here. So I could plug it in tangent inverse of phi over 2 equal to theta. So we could replace this guy with theta. Sine theta. What is a sine theta equal to? Sine, that will be opposite over hypotenuse. So 3 over rad 13. And then we need to rationalize. So times rad 13 over rad 13. Final answer, 3 times rad 13 over 13. Okay, this kind of the example, make sure you guys remember the range of the inverse function. Figure out which quadrant is gonna be of your theta. Okay, if you figure out that will be quadrant 4, then the answer is gonna be different. B, tangent of cosine inverse of negative 5 over 13. So think about it. What is the range of the inverse cosine? That is from 0 to pi, right? So cosine 1 and cosine 2. And then cosine has to be negative. So you know the angle has to be in cosine 2. And then we're gonna let A is in the cosine 2. Now we're gonna say let A equal to cosine inverse of negative 5 over 13. So cosine A, that will be equal to negative 5 over 13. And then angle A will be in cosine 2. So let's sketch A in the cosine 2. So cosine A will be adjacent over hypotenuse. And then let's try to find out the opposite. Plug it in. You should get y equal to 12. Okay, now we're gonna go back to this guy. So we're gonna replace the cosine inverse of -5/13 equal to A. And then tangent A will be opposite over adjacent. So that will be equal to 12/-5. Example 6. Evaluate the expressions without a calculator. Cosine of arctangent square root 3 plus arcsine 1/3. So first, we're gonna let A equal to the arctangent square root 3. Then tangent A will be equal to root 3. And then we do have another part here. So we're gonna let B equal to arcsine 1/3. So sine B equal to 1/3. Now we're gonna plug in back to here. So we do have a cosine A plus B. Think about it. A should be in which quadrant? Think about the range of the arctangent. The range of the arctangent should be quadrant 1 and quadrant 4, right? And tangent will be positive on the quadrant 1. So angle A should be in quadrant 1. Same idea for the arcsine. The range of the arcsine should be quadrant 1 and quadrant 4 again. So sides are positive, that will be in quadrant 1 also. So both A and B is gonna be in quadrant 1. And then we're gonna sketch these two angles in the quadrant 1 here. So one is the angle A, which is gonna be tangent A equal to root 3/1. So opposite over adjacent, root 3/1 here. And then angle B, opposite over hypotenuse, so 1/3. Now, I want you guys try to find out what is the R. Okay, check your work. You should get R equal to 2. And then for this triangle, so you should get x equal to 2 square root 2. Okay, right? Now, we're gonna keep working on this guy. We do have a cosine A plus B. Then we're gonna use the formula. Remember what is it? Cosine A, cosine B minus sine A sine B. Now, we're gonna use this two triangle. Cosine A, that will be 1/2. Cosine B, that will be 2 square root 2/3. Sine A, that will be root 3/2. And then sine B, that will be 1/3. Now we're gonna simplify it. So 2 and 2 we could cancel out. You should get this guy. Okay, you could just leave this as your final answer or get the same denominator. You're gonna times 2 here, times 2 here. Okay, both of them can be the final answer. Example 6. Evaluate the expressions without a calculator. Tangent of 2 arcsine 2/5. So we're gonna let the angle. And I only let the angle B equal to arcsine 2/5. Okay, the 2 still here. Then that will be sine B equal to 2/5. And then we plug in back here, you're gonna get the tangent 2B. And then we're gonna use the double angle formula. Okay, tangent 2b equal to 2 tangent b 1 minus tangent square b. We're going to use it here. Now think about it. Arc side, the range of the arc side should be quadrant 1 and quadrant 4, and then side b will be positive. So we're gonna sketch the angle B in the quadrant 1 here. And then we're gonna calculate the x. You should get x equal to 21. Okay, write it down here. Now, we want to find out what is the tangent B. Tangent B will be equal to 2 over 21. I didn't rationalize it because I will do it at the end when you have the final answer. Okay, so I would just do 2 over square root of 21. Simplify it. And then on the bottom, you're gonna get the same denominator. So 21 minus 4, which is 17. And then simplify it. I don't have anything to simplify, so I'm gonna do rationalize. So I'm gonna multiply 21 over 21. So 21 times 21, I'm gonna get 21 here. Now I could simplify it. So that would be my final answer. Okay, example 7. Write sine of tangent inverse u has an algebraic expressions in u. So I want you guys simplify this guy in terms of u here. So first, I'm gonna let theta equal to tangent inverse u. Then tangent theta, that'll be equal to u. And then u, they didn't specify, it can be positive or negative. And then the range of the arctangent will be from negative pi over 2 to pi over 2. So the theta, it can be in quadrant 1 and quadrant 4. So let's try to sketch both triangle, quadrant 1 and then quadrant 4 here. And then when u is greater than 0, theta will be in quadrant 1. When u is less than 0, the theta will be in quadrant 4. Okay, now let's try to find the hypotenuse. And then both of the hypotenuse should be positive. So r equal to square root of 1 plus u squared. Okay, now we go back this guy. We have a sine of tangent inverse u. And then what is the tangent inverse u equal to? That's going to be equal to theta. What is a sine theta? Okay, for the quadrant 1, sine theta will be u over square root of u squared plus 1. And then for the quadrant 4, same idea. That will be u over square root of u squared plus 1. And this guy will be positive or negative. It really depends on your u here. And then we are not done yet. We need to rationalize. Okay, so we're gonna multiply square root of 1 plus u squared. Simplify it. That's it. We just want to in terms of u here. Okay, B. Same thing, we're gonna let theta equal to sine inverse u. So sine theta will be equal to u here. We plug it in, so we have a cosine 2 theta. And then we can use the double angle identity. Do you guys remember that you do have 3 equations for the double angle identity when you have a cosine 2 theta? Okay, I will choose cosine 2 theta equal to 1 minus 2 sine squared theta because I already know what's a sine theta equal to u. Okay, So plug it in. And sine theta will be equal to u. So I do have a 1 minus 2u squared. If you guys didn't choose this identity, let's say I choose the identity of cosine 2 theta equal to 2 cosine squared theta minus 1, then I will use the sine theta equal to u. I need to sketch the triangle in the quadrant 1 and quadrant 4. Okay, you're gonna get the same answer. Okay, it just like spend more work here. That's it.